In previous video, we talked about the introduction to Surds, and we discussed the first three rules that you can see on the screen. A multiplied by B under the square root, we can break it into two, we can divide it, and we can rationalize the denominator. In the fourth example, you notice we have addition and subtraction. So we are saying A square root of C plus or minus B square root of C. If you notice, we have two common terms there. That is a square root of C and square root of C. And to be able to solve this further, we can treat it as a like term, or we can say is a coefficient or a variable that we can take out, and then we can have the rest multiplying each other. So let's just go further and break this down with two examples. So in this example, we have 2 root 3 plus 5 root 3. How do we solve this? We want to treat square root of 3 in each case as a variable, because it's an irrational number that we cannot add on its own. So instead of worrying so much, we can just keep them outside, and we can have 2 plus 5. You can put the square root on either side that you like. So it could be root 3 and 7, or it could be 7 root 3. So you notice in this case, because we have a common term on both sides for square root of 3, we had the coefficient outside, 2 and 5 together, to obey the fourth rule. Another example we can use to drive home the point, we have a 6 root 5 plus 3 root 5, and again you can see the common terms here, root 5 and root 5. So in this case, we can have 6 plus 3, and then we have root 5. It doesn't matter which side you place square root of 5. It could be before, it could be after. So what matters is the final answer. 6 plus 3 will give us 9 root 5. So this is the fourth rule. Now, it gets interesting when we get to the fifth rule. And let me first explain it based on the third rule that we discussed. In this instance, we have a numerator, and we have A plus B square root of n. Now, we need to do something about this, because in the denominator, we have an indices that is staying there. And that is why we need to act to rationalize it. So in this case, we're going to rationalize the denominator. And in the process, we're going to multiply. So let me just write it out here. Multiply the top, which is the denominator, and the bottom by A minus B square root of n. So the opposite of this numerator. So we are going to do it that way. And let's assume we have C over A minus B square root of n. We are going to multiply top and bottom by A plus B root n. And this helps us to explain the conjugate that we're talking about. So please be aware, anytime you have to rationalize where we have addition, when you're rationalizing, in order for it to cancel out, you multiply the numerator and the denominator by the opposite sign. And in this case, if we have a negative, we multiply the numerator and the denominator by the positive sign. So we're going to look at one example or two as time permits us to be able to drive home this point. So take for example, we have a 3 over 3 plus root 2. So in this case, we cannot leave our final answer. We have to rationalize. So since this is plus, what are we going to rationalize with? So the first thing we want to do is determine what you are going to multiply with. So this will become 3 over 3 plus root 2 multiplied by 3 minus root 2 over 3 minus root 2. We just want to use this as a basic example to help us understand the concept. We can elaborate further in the subsequent video. So here we have 3 over 3 plus root 2 multiplying 3 minus root 2, 3 minus root 2. So you notice we have an opposing sign. Our original question is positive, and we rationalize with an opposing number. If this were to be negative, we are going to rationalize with positive number. So let's go further and solve this. So this will become 3 will multiply 3 minus root 2. And this will be 3 plus root 2, and then 3 minus root 2. So to solve further, we can come to this side and have our numerator. So this 3 will multiply this 3. So that is a 3 times 3. And this 3 will multiply this minus 2. That will be minus 3 root 2. Now, this one, we're going to apply that same rule. This 3 will multiply this 3. So we have 3 times 3. And this 3 will multiply this minus 2. We have minus 3 root 2. And then we have this 3 will multiply this root 2. This will be plus 3 root 2. Then we have plus root 2 multiplied by minus root 2. So we have, in this case, plus root 2 multiplied by minus root 2. So further, this will be 3 times 3 will give us 9, and 3 root 2 over 3 times 3 is 9. And if you look at this, this is minus 3 root 2 plus 3 root 2. You have $2, you are owing $2. If you pay your debt of $2 from the $2 you're owing, what do you have left? 0. So we ignore that because this automatically cancel out. Then plus times minus will give us minus, and then we have square root of 4. Because of root 2, this is a root 2 times root 2. That is a root 4. So in this case, we have 9 minus 3 root 2 over 9 minus square root of 4. Now, if we solve this further, we're going to have 9 minus 3 root 2 over 9 minus 2, because square root of 4 equals 2. So our final answer will be 9 minus 3 root 2 over 9 minus 2 will give us 7. In this instance, we can solve it this way. We can still break it down further. That what is common to both sides, I think 3 is common, and we'll multiply 3 by 3 to give us 9 minus root 2 over 7. So you can see in this instance, this is how we handle this rationalizing the denominator. Like I just mentioned previously, the sixth rule is just the opposite side we mentioned, and I'll repeat it just for emphasis. So we have c over a minus b root n. So if we rationalize, this will be c over a minus b root n multiplied by a plus b root n over a plus b root n. And that is the sixth rule. So when we are solving it, we'll be able to apply the principle better. So these are the 6 rules that we want to keep in mind. In the next video, we'll be talking about basic skills in Surds. Thank you very much for watching this video. If you are benefiting from this video, please like the video and subscribe to this channel. See you in the next video.